Hi, my name is Kristen. Welcome to this journey through space. Today, we are going to study the chapter, which is Basics of 3D Printing. In this session, we'll explore how 3D printing works, compare major printing technologies, understand slicer software, review materials like PLA and ABS, and go through calibration and troubleshooting. You'll also get a walkthrough of your first print. Let's begin shaping ideas into physical reality. 2. 3D printing technologies. Overview. 3D printing builds objects layer by layer from a digital model. It includes different technologies, each suitable for specific needs. The three most common methods are FDM, SLA, and SLS. Understanding their core differences is essential for making the right choice depending on application, cost, and material requirements. 3. FDM, Fused Deposition Modeling. FDM works by melting plastic filament and depositing it through a heated nozzle. It's widely used in hobby and educational setups due to low cost and ease of use. Although not the most precise, it's ideal for functional prototypes. PLA and ABS are commonly used with FDM printers. 4. SLA, Stereolithography. SLA uses a UV laser to solidify liquid resin. It's known for producing very fine details and smooth surfaces. However, SLA is more expensive, messy, and requires post-processing. It's mainly used for detailed models like dental or jewelry prototypes. 5. SLS, Selective Laser Sintering. SLS uses a laser to fuse powdered material like nylon. Since the powder supports the part during printing, no separate supports are needed. SLS is preferred for industrial-strength parts, though machines are costly, and parts have a slightly rough finish. 6. What is slicer software? Slicer software converts your 3D model into layers and generates G-code for the printer. It defines how the object is built: layer height, speed, infill, and supports. Good slicing directly impacts print success. Two common slicers are Cura and Prusa Slicer. 7. Cura, Easy and Versatile. Cura is beginner-friendly and supports many printers. It offers pre-configured profiles and lets users tweak essential parameters like layer height, supports, and infill. Its visual preview and plugin support make it great for getting started. 8. Prusa Slicer. For advanced control, Prusa Slicer is preferred by experienced users, especially with Prusa printers. It allows fine-tuning, variable layer heights, and multi-material prints. While more complex, it provides deep customization options, helpful for advanced projects. 9. Layer height and infill settings. Layer height determines resolution. Smaller layers yield smoother results, but take more time. Infill controls internal structure. Higher infill means stronger parts, but more material use. Choose based on the part's purpose, display, or function. 10. Supports and print orientation. Overhangs in a model require supports to print correctly. Slicers generate supports automatically, but manual adjustments are often better. Orientation impacts print success, strength, and surface finish. Optimal placement reduces supports and improves quality. 11. PLA, Beginner's Material. PLA is easy to print, biodegradable, and ideal for beginners. It doesn't need a heated bed and has minimal warping. It's great for prototypes and visual models, but isn't very strong or heat-resistant. Available in many colors and effects. 12. ABS, Tough but demanding. ABS is more durable than PLA but needs a heated bed and good ventilation. It warps easily, so enclosure helps. It's used in automotive and structural parts. Though tricky to print, it offers great strength and can be post-processed with acetone. 13. PE Taiji, Balanced choice. PETG is tougher than PLA and easier than ABS. It's semi-flexible, water-resistant, and ideal for functional parts. It prints with minimal warping, but needs precise cooling, suitable for outdoor use and mechanical applications. 14. Printer calibration. Before printing, calibrate your machine. Level the bed, check nozzle height, and ensure accurate filament extrusion. Use simple calibration models like cubes to verify accuracy. A well-calibrated printer reduces errors and ensures smoother prints. 15. First print walkthrough. For your first print, start simple. A small model or calibration cube. Check slicer settings, material loading, and bed leveling. Watch the first layer closely. It sets the tone for the whole print. Expect some trial and error in the beginning. 16. Common print issues. Problems like stringing, under-extrusion, and layer shifts are common. Stringing occurs due to bad retraction settings. Warping comes from poor bed adhesion. Loose belts can cause shifting. Understanding these problems helps reduce failed prints. 17. Functional part example. Consider designing a wall bracket. Use PETG or ABS for strength, and choose 50% plus infill. Design for real-world stress. Add chamfers, fillets, and oversized screw holes. Post-processing, like drilling or inserting metal threads, improves usability. 18. Artistic print. Example. For decorative models like statues, PLA is ideal. Choose fine layer height, 0.1 meter, for smooth finishes. Orient the model to minimize visible seams and support marks. Post-process with sanding and painting for professional results. 19. Summary of concepts. We covered key technologies: FDM, SLA, SLS, slicers like Cura and Prusa Slicer, and how settings like layer height and infill impact prints. We discussed materials: PLA, ABS, PETG, calibration, and common problems. With this foundation, you're ready to start printing. 20. What's next? Now that you know the basics, try slicing and printing a small object. Play with slicer settings, test different materials, and analyze the results. In the next chapter, we'll explore design for 3D printing, how to model parts optimized for fabrication. Until then, happy printing.